Okay, so here is general force being diced. Also, again, I'm holding to it around 6 to 9 months. After that, it goes to charges or taxes or both. This is to have a certain level of capital for the coming months to be allowed to give to charities and taxes next to it. So I produce next to it again for charities and taxes. So this is 971 force and invention till hopefully 976. That's it. So I'm going on with that. Yeah, me being PhD Alborz, Seddigh, Afshar again. Yeah, okay. And it is 20 May 2015, and it's 10 o'clock 06, May 20, 2015. Okay, nasty one. N. Okay, bizarre combination. Okay. So NST. So NST is N is a mass because it's amount per mass per amount times amount is mass. So N relates to mass to amount per Avogadro number. Mass per Avogadro number times the number. S is seconds, T is temperature. So you got mass, seconds, temperature. I didn't use the E. That would have turned it to electromagnetical. Do I take on the extra challenge of using the E for electromagnetic or energy? So I'm going to use the E for energy. So I'm going to say mass is temperature times mass is energy of that it contains. So if there's more mass in a certain amount it's got more heat stored in as an energy. If the temperature is higher, it's also storing more heat. So mass, let's say PV is KT is E, but I said in K should be included also is E, also the mass. So it's actually flow times mass times temperature is E. And mass being mass per n times n, mass per number times n. So I say it's now PV equals E is KT. I say it's PV equals E is flow 133, I think 230. I'm not sure. Yeah, 230 something equals times mass times temperature. That is actual energy. So if there's also more mass in there at that temperature, there's also more energy, not just because mc squared, that more mass leads to more energy in nuclear reactions, but also because if there's a large amount of mass at a certain temperature, there would be total contained energy would also be higher if there's a larger amount of mass at a certain temperature. So I think I'm going to define that force that way. That I think the K should KT of equals PV equals E should contain, the K should also contain a certain mass term. So that's intuitive physics, not intuitive that would occur to you, but that's probably true, because if you have more water at a certain temperature, it contains more net energy. You start reasoning that compared to if you have a drop of water, compared to a sea of water at a certain temperature, it has more, so it's temperature per mass also. That is also that is a part of that formula. So as a physics force, I would say more mass is more N is more energy also then. because temperature per mass is also higher. So as a force of physics, as a machine, I would say, for instance, if you have a smaller amount of in an engine, if you have a piston engine, if you have a smaller amount of combustion material, smaller mass of combustion material, you achieve less energy with that, next to obviously if the temperature is lower of the combustion material. So that's already obvious. So if you input more gas into an engine, you would expect the engine to get a bigger response if it starts combusting. If you start inputting more gas, but they might have not been onto that. They would have just said it's just the temperature of the according to formula. According to them, it would have been just the temperature. They wouldn't have been onto this particular new physics formula. So I would say more gas being put into the engine causes per combustion of the piston would cause greater energy. So more gas being put in next to just the temperature being higher when the particular type of gas combusts. So if it's kerosene, might combust at a higher temperature than, for instance, some paraffin oil. That would be there. Yeah. So more mass of it, more, and also higher temperature, higher end temperature of the particular type of combustion material would cause stronger combustion of the pistons, for instance, as a type of better engine you can lose from the force. And then next to it, I would say this particular engine could be used in a rocket pump. Can be used in a rocket pump, in effect. Next to it, making it embryology physics. So that would be embryology, engine, better engine, and a force. So I got force, better engine, and embryology. That's 3. Then all these things in exponential, above exponential, and linear force. So I would say linear, exponential production of it, and also just in forwards, and also the production of it, and also the workings of it, linear, exponential, and above exponential. So linear, exponential, that's 5, and above exponential, that's 6. Then I would say it's not just piston engine, it's also generators, in effect. That it's not just the engine creating kinetic energy, it's also engine creating electricity, not just as a cause of causing propulsion for a car or something, but also for causing electricity. So in a generator too. That's 4th one. Also you can say generator for the rocket pump. That's 5th one. So I would say I will count this altogether also as another set of 6, for instance, even as it could have been counted as more. With a new force again, that's it. A new force, new possibilities, better engines, better generators, and maybe better dynamos. But a dynamo obviously is running off the kinetic force that the engine produces, which is a type of generator. So I would say that's just generator in that case. It's a combustion sense. Okay, so that's it. So that's Leonard Forsyth, and the flow aspect. Let me think about that. So I had amounts per time. Energy, no, amount of energy, temperature. Okay, so what I would say as flow is this equals PV. Now V per T is a flow. So if I divide this energy per distance is a force. So per distance is a force. So it's P flow mass temperature is energy. Okay. This per distance is force. Okay, there's a new force there, and this equals PV per distance as a force, and this PV, the V of it per time is a flow, so I have to multiply times time. So it's divided by velocity, in effect, because it's T per X. Okay. So it's PV, P times flow, pressure times flow times divided by velocity. Okay, that would turn it into a force again, as a type of flow force. Okay, so that would be V per T. Okay, that's flow times T, and it's also PV divided by X, so there's a T per X there, so that's divided by velocity, so that's P times flow divided by velocity. That would be a force in itself also in that sense, with the flow being the, I think, later flow, I think it's 30 something flow, I think 34th, I'm not sure. Yeah, so that's it. So that would be a flow force there too, next to a regular force. That's it. So I would say that's 7th, and so I'm running out of time, so I'm not going to continue.